Hi friends, and in today's tutorial we'll understand a few basic operations on Numpy. So you launch your Jupyter notebook and the home page looks like this since I have so many files and folders. So then I go to my folder called Python tutorial and I will open it. It's been arranged alphabetical wise. So I open this and in that I would go to new Python 3 notebook, and in this I will rename this notebook by hitting on untitled, and I will rename it as Numpy, and I'll rename this. Okay. So we talk about Numpy. So what is Numpy? Now this is a library in Python and it is used for linear algebra, and you can say it's for matrix multiplication, multiplication, and it's also used for your arrays and arranging arrays in various formats for scientific computing, right? Yes. So, and you can go for its documentation for more details about if you want to really go in details about what does it really means, NumPy. And I have one video also, so you can just go and watch this video, and this tells about all the libraries in Python, the basic one being pandas, numpy, scipy or scikit-learn. Okay. I'll provide it in the end of this thing. So end of this video. Now let's mark it down, or I can just convert it into raw and be convert and hit shift enter. Now let's understand this numpy. What I do is I have to write one command as import numpy as np, and this will be imported from this library from Python, this package, and then I will have this. I will want to print its version, so I will write np dot, and I can give this version, and it will tell me the version of it, and it is 1.18.1. This version keeps on changing and it's been updated most of the time because it's an open source, so it keeps on updating. Okay, so what I want to do is I will now create a one-dimensional array. Okay, and this will be having like around 10 elements, or if you want more you can add those elements as per your wish, and convert it into a heading. And now what I did was I clicked on 2, like it was like this. I clicked on, when this is a blue bar here, I click 2 and it gives me 2 hash, that means it's heading 2, and you can then hit shift and enter. Okay, so now you make an object called arr, and there you call this np dot arrange, and this is numpy. Numpy will arrange 10 elements in one dimensional array. Then what you do is you call this arr and hit shift enter. So you can see this array of one dimensional has been created. Okay, now what you do is, the next thing we'll do is you create an array. Okay, I will not use this, I will do this simple. So I create a boolean array, right, and this would be a 3 by 3, 3 by 3 numpy array, and all values will be all true values. Alright, so let's see how this is done. So what I do is I again create an object called arr, and in that I write np dot repeat, and there I write true, and I write 9 because I want 3 into 3, so this has to be 9, and then dot reshape and this reshape will give me 3 comma minus 1. Call this ARR and you shall see this matrix. So you see here that I want true 9 times, repeat true 9 times. That's what I give the command, and I tell it to reshape this matrix in the form of 3 and minus 1. This is the axis, and the 3 rows, right? Okay. So now I want to, like, suppose extract all odd numbers, okay? Odd numbers from ARR. What I do is I give this ARR as again np dot range, and you can just give 10. It will be arranged in 10. Alright, so just print here ARR. So this is the same thing. Then what you do is um, print ARR. Now what you do is you give a condition, like, because I want all odd numbers, I want all odd numbers. That means odd numbers when it is not divided by 2. So the same condition I will give in just one line. I will say that odds equals, and I will write in ARR. What you do is when my element in array, its remainder, when it is divided by 2, when it is divided by 2, it is not equal to 0. What you do is you print what? Odds. Okay, so it has given me all the odds like 1, 3, 5, 7, 9. Now suppose I want evens, so I can just reverse the condition as ARR, and I will write that ARR when this is divisible by 2 and is equal to 0 remainder, then print evens. This will give me, alright, here you have to write equals 0, and it will give me all the even numbers in this array. This is how you will select it, giving a condition of if it is divisible by 2 and the remainder is 0. This is a modulus operation telling you that this means that this is remainder if divided by 2 is equal to 0. Then you give me even, and if it is not equal to 0, you give me odd. That is what I have used simply. Now what you do is, let's take one more thing, okay, and let's see what is ARR again. Okay, we've got this list of element ARR. Now what I want is I would replace all odds with, suppose I want to replace all odds in ARR with minus 1, right? And okay, I wanted a heading, but okay. So what I do is I again give this ARR, and I know this ARR is this here. So now what I do is I write here ARR, and I simply, this is very easy, like, see, I will simply write here what I will write ARR equals, and then you equals ARR, and in this I will give you, or I can simply write equals ARR, and if this is not equal to, if this is divided by 2 is remainder is not equal to 0, right, and equals to, then you replace it with minus 1, and you print this ARR. Okay, so see, all the odd positions are being replaced by minus 1. So instead of giving here odds equals to odds, I'm replacing it with minus 1 now. So I'm not removing. What is the difference here? That the elements like 0 and 2 for the even elements have been removed here, but in this we are not removing the even elements, but we are replacing the odd elements. So my array element size remains the same. right? And here I just gave this condition and this was odds. Here I replaced it with -1. Okay. Okay. So now what's next? Now I show you something interesting. Now suppose ARR equals to, if I give np dot arrange and I say you go from 0 to 11 to 2, and you didn't print ARR, right? Or you simply write ARR. See, what happens here is it goes for like a for loop and it arranges elements from 0 to 10, 11, that means 0 is again included, in an interval of 2. Okay, so 0, 2, 4, 6, then 2, then again 2. Okay, right. Now suppose if you just play around with these things and you can just put here 12, and let's see again. So it has to be 13 so that it can go till 12. Okay, because it is arranging itself into. Now suppose I change it to 3, then you will get it in the multiples of 3. Okay, and if you want to really print a table, just give from 0 to 30 and a table of 3. Your table of 3 will be printed. So just increment it by one more table of 3. If I want a table of like 4, so I can just give here 45, or a number greater than um, let's say 144, and let's put it in interval of 4, and let's see what happens. Okay, so you've got a table, I mean a huge table of 4. So this is how you can just play around with Numpy. Okay, and it will give you arranged metrics in the interval as per your need. All right, now what I want is I now what if I want to convert um, one dimensional array to a two-dimensional one. Two-dimensional, and also okay, this is two-dimensional here with the 2 rows. Okay, and I convert this into a heading by heading 2. Yes, what I do is I give this ARR equals np dot arrange. Again, I'll take the 10 elements, and what I do is I print this ARR. Now what I want is, I want a solution. So I will first show you and then I will tell you what I really want. Reshape 2 comma, and this is what I give you. So this is what I wanted. I wanted a one-dimensional array. I had one-dimensional array with 10 elements arranged in just one array. Now I have converted this one-dimensional to a two-dimensional array like this in 2 rows. Okay, so if you want to reshape it with suppose 3 rows, so, and see, I just changed this 3, but I have not done anything with this element. Let's see what it does. It throws an error. Okay, because if you cannot reshape the size of 10 into the shape 3 and new axis, it has to be a multiple of 3 to be arranged in that order. Now see, it has arranged it in a form of a array, and these 3 rows have been arranged, and 12 elements have been arranged like that. If you want 4 rows, so 4 rows, this is how it would be arranged. Okay, so you can play around with this, and suppose if I so let's restore this back to my 2, and here let's get back to 10. Okay, now another thing we'll see is if I want to stack let's say stack arrays, like A and B vertically. How would I stack these arrays vertically? So what I do is whatever 2 arrays I have, like suppose I give one array as A equals, and in that I arrange let's say 10 elements, and I can just give here only that you reshape this into two columns, two rows, and arrange them in a form of a matrix. And in B I just give you np dot range, and what you do is you repeat 10 to 1 repeated 10 times, and you also again then reshape it in the form of 2 and minus 1. Okay, and then you print here A, enter B, and then what you do is here I will give you here the solution will come, and you simply write here that print solution is or solution of, or you can just write solution vertically stacked arrays, and you hit enter and just write np dot vstack as stack, and in this you'll give A and B. Okay, hit shift enter and we got some problem. 1 comma 10 reshape 2 comma minus 1 shape 9 into 2. Okay, so don't shape it. Let's see. Okay, actually I had to what I did is like I gave her just one. I had to start from zero in that case. So it has just stacked these two arrays vertically. Okay. So you can see here this element starts from 0, and here I have a sign that you start from 1 to 10. It can do this also. Okay. Alright. Next, let's come to stacking this array horizontally. How would I stack this? Now you stack horizontally. Stack horizontally. So for stacking horizontally, what you need is, again, you just assign A as np dot. I'll show you one more feature here. Arrange, and in this you take 10 dot, then reshape it as in two rows. I want this, and in the second thing I want here as np dot. I would say repeat. Let's use repeat here, and in this repeat, this will be repeated 10 times, and reshape. Actually I wanted to write repeat here, but I wrote arrange here. Okay, fine. Okay. Then here 2 comma minus 1, and then what you write here, you write print solution, and you can write horizontally stacked, and simply write np dot h stack A comma B. This is for matrix, this is for arrangement of matrix, so I've given these two brackets. Okay, so see, this has been arranged horizontally. So this is the A element, and this is the B element, right? Okay, now what else I want to show you? I just want to show you one more thing. Like suppose if I simply want like ARR, if I just a basic thing, and you can it's just a revision of what we did, like arrange a matrix like in a form of 20, and I give this reshape, and I want to reshape in a form of suppose 6 comma 5. Then see what happens, and you write here ARR, and you find that 30 elements have been arranged in 6 rows and 5 columns. Okay, so you've got 6 rows and 5 columns. Okay, now okay, this has to be converted into raw and be converted. Now, what if I give this ARR dot sum? I want to sum my matrix and x is equals to 1. Okay, let's see what it gives me. Okay, this has given me 10, 35, 60, 85, and this. So how are we getting this 10? So we are getting this by adding 4. So you add these elements 7, 8, 9, 10. So you add this first row, you'll get 10. Add the second row, you'll get 35. 5, 6, 11, 11, 7, 11, 7, 18, 18, 8, and 26, 26 plus 9 is 35. This is how you go on adding these elements. In X1, it will go and find out the 5 elements where they are, and they will add them and give you. Okay. Now, if I want to show you something else, if I write sum and I go to x is equals to 0. Okay. And I write here x is equals to 0. What will happen next is it will add the vertical columns, right? 5 plus 10, 15, 15 plus 15, 30, 30 plus 20, 50, 50 plus 25, 75. So this is how it is adding up. Okay, x is 0, columns would be added, x is 1, the rows would be added. Okay, so this was your array. And suppose if I want to experiment some more thing, like if I what was I doing here, if I just simply ARR equals to, if I write here np dot arrange and I arrange it in 30, and then again I reshape it to suppose 2 comma minus 1, that was I was doing, and you call this ARR. So can you see this, how this has been arranged into 2, and this is quite vast, so we just want to make it more presentable, and so the matrix has been arranged in such a manner so that it can be understood in a good format. So that's why I give like small shape and small numbers, but if you want larger metric, depends upon your requirement. Okay, so play around these numbers, and it is very fun to work with Numpy because it makes calculations, scientific computations, complex multiplication and addition, subtraction, mathematics very easy for your data science projects, for your machine learning projects and whatnot. Unimaginable simplicity it has brought to Python. So that's it for this video, and in the next video we shall see pandas. Okay, and thank you for watching.